In 1982, divers exploring the Mediterranean discovered one of the greatest shipwrecks ever found. Buried beneath more than 3,000 years of sand lay a cargo unlike anything archaeologists had recovered before. Gold from Egypt, ivory from Africa, glass from the Near East, luxury goods collected from across the Bronze Age world, but none of those objects became the ship's greatest mystery. That honour belonged to 10 tons of copper. For years, historians believed they already knew where that copper had been mined. It seemed like one of the easiest questions surrounding the wreck. Then scientists tested the metal. Some of the copper matched the mines everyone expected. Some of it didn't. The laboratory wasn't suggesting a new answer. It was exposing a problem, because part of the cargo refused to fit comfortably with the best-known Bronze Age copper sources. Researchers proposed different explanations, but the question remained open. As investigators searched for another source, the trail led somewhere almost nobody expected to look. Not another island in the Mediterranean. Not another forgotten mine in the Near East. It led toward the shores of Lake Superior, where thousands of ancient mining pits had already been discovered beneath the forests of North America, along with evidence that enormous quantities of native copper had been removed thousands of years before European contact. Could one Bronze Age shipwreck help explain one of America's oldest archaeological mysteries? Or is the connection nothing more than an extraordinary coincidence? Today we're following the evidence from the bottom of the Mediterranean Sea to the prehistoric copper mines of Lake Superior to examine a question that historians, archaeologists and scientists are still trying to answer. When the first diver surfaced off the coast of southwestern Turkey in the summer of 1982, he wasn't celebrating a discovery. He was trying to understand what he had just seen. Nearly 150 feet below the surface, his equipment had caught against what appeared to be an ordinary outcrop of rock. Curious, he swam back for a closer look. As the layers of marine growth came into focus, he realized the object wasn't part of the seabed at all. It was metal, and it wasn't alone. More pieces lay scattered down the slope, arranged in rows as though an entire cargo had spilled from a vessel that vanished thousands of years earlier. At that moment, nobody knew they were looking at what would become one of the most important archaeological discoveries ever made beneath the Mediterranean Sea. The wreck would eventually become known as the Uluburun Shipwreck, named after the nearby cape where it was discovered. What followed was not a quick excavation. Beginning in 1984, archaeologists returned season after season, spending 11 years recovering every object they could find. Every dive required careful planning. Every artifact had to be documented exactly where it rested before it could be moved. Thousands of underwater photographs were taken. Every basket of sediment was examined because even the smallest object could reveal where the ship had travelled and who had loaded its cargo more than 3,000 years earlier. As the excavation continued, the ship slowly revealed the world it had once connected. Large storage jars from Canaan still contain traces of their original contents. Glass ingots coloured an intense cobalt blue rested beside elephant tusks and hippopotamus ivory imported from Africa. There were ebony logs, fine pottery, gold jewellery, delicate balance weights used by merchants, and one object that immediately attracted international attention, a scarab bearing the name of the Egyptian queen Nefertiti. No single kingdom had produced this cargo. It represented merchants, craftsmen and trading partners spread across much of the known Bronze Age world. The ship was carrying a floating marketplace, collecting goods from different civilizations before continuing toward its final destination, a destination it would never reach. For archaeologists, the wreck was extraordinary because ancient ships rarely survive in this condition. Wood usually disappears, organic materials decay, cargo becomes scattered by storms and currents. Uluburun was different. The seabed had protected it with remarkable care, preserving a moment of international trade almost as if time had stopped the instant the vessel sank. It allowed researchers to examine not just individual artifacts, but an entire commercial network exactly as it existed during the late Bronze Age. Yet among everything recovered from the wreck, one group of objects quickly became the centre of attention. The copper not because copper was rare, because there was so much of it. Archaeologists recovered 354 massive oxide ingots, together weighing nearly 10 tons. Each ingot had been cast into a distinctive shape that made it easier to carry across a person's shoulders and easier to stack inside the ship's hull. It represented one of the largest Bronze Age copper shipments ever discovered. To understand why that mattered, it helps to remember what copper meant 3,000 years ago. Today we build our world with steel, aluminum and electricity. The Bronze Age was built with copper. Mixed with tin, it produced bronze, the metal used for swords, axes, chisels, armour, farming tools, ship fittings, and countless objects that supported everyday life. A kingdom with reliable access to copper possessed an enormous economic advantage. Control the copper supply, and you influence trade routes stretching across the eastern Mediterranean. That is why archaeologists believed they already knew where the Uluburun cargo had originated. The answer seemed almost too obvious. For generations, Cyprus had been recognized as the great copper producer of the Bronze Age. Its mines supplied kingdoms throughout the region, and even the Latin word cuprum, from which the modern word copper is derived, reflects that long association with the island. The cargo appeared to fit perfectly into that history. There seemed to be very little left to debate. Then the laboratory results arrived, and one of the most straightforward questions surrounding the ship suddenly became the most complicated. For almost everyone studying the Uluburun shipwreck, the question of where the copper had been mined seemed settled before the first laboratory test was ever performed. The Bronze Age Mediterranean had one supplier that stood above all the others: Cyprus. Its mines were famous in antiquity, its copper circulated across the eastern Mediterranean for centuries, and its reputation became so closely tied to the metal that the Latin word cuprum eventually took its name from the island itself. Looking at a ship carrying more than 10 tons of copper, most archaeologists naturally expected the laboratory to confirm what history already appeared to know. But archaeology has a habit of becoming more interesting the moment evidence enters the laboratory. Objects can be copied, stories can be exaggerated, trade routes can be misunderstood. Chemistry is much harder to persuade. Every major copper deposit formed under different geological conditions millions of years ago. During that process, tiny variations developed in the metal's lead isotopes. Those variations remain inside the copper no matter how many times it is melted, traded, recast, or transformed into weapons, tools, or ingots. To archaeologists, those isotopes function much like a fingerprint. They cannot tell you who mined the copper, they cannot tell you who owned it, but they can often identify the geological region where the metal first entered human hands. It is one of the most powerful tools available for reconstructing ancient trade networks because the copper carries the memory of its birthplace, even after travelling thousands of miles. When researchers began comparing the Uluburun ingots with known copper deposits across the Mediterranean, much of the evidence behaved exactly as expected. Several samples showed good agreement with established mining districts. That was reassuring. It suggested the testing method was working and confirmed what decades of archaeological research had already proposed. Then other samples began producing results that refused to fit as comfortably. Some ingots could not be confidently matched with the major copper sources historians had long considered the backbone of Bronze Age trade. The mismatch did not immediately point to a new origin, nor did it overturn everything researchers thought they knew. It simply introduced uncertainty into a question that had seemed remarkably straightforward before the testing began. That distinction is important because it is often misunderstood. The laboratory did not conclude that the copper came from North America. It did not announce that the Bronze Age world was importing metal across the Atlantic. Scientific papers were far more cautious than that. What the analyses demonstrated was that some of the copper could not yet be confidently assigned to the best-known Mediterranean sources using the available comparative data. Those are very different statements. One is a conclusion. The other is an unanswered question. Good archaeology depends on recognizing the difference. Researchers propose several explanations. Perhaps additional ancient mining districts in the Mediterranean had not yet been sampled. Perhaps the existing isotope database was incomplete. Perhaps future discoveries would eventually identify deposits whose chemical signatures matched the unusual ingots more closely. All of those possibilities remain active areas of research, and each offers a perfectly reasonable scientific path forward. The important point is that none of them completely close the discussion. The laboratory results left enough uncertainty that the search continued. As scientists expanded their comparisons beyond the traditional Bronze Age mining regions, one location appeared in conversations often enough to attract attention. Not because it proved anything, because it possessed something almost impossible to ignore: an immense prehistoric copper district, thousands of ancient mining pits, evidence that astonishing quantities of native copper had been extracted thousands of years ago. That place was not in Cyprus, it was not in Egypt, it was not in Anatolia, it was nearly 5,000 miles away on the southern shores of Lake Superior. At first glance, the suggestion seemed almost absurd. A Bronze Age shipwreck resting beneath the Mediterranean Sea had somehow reopened a mystery buried beneath the forests of North America. The two places were separated by an ocean, separated by civilizations, separated by everything historians believed they knew about the ancient world. Yet the deeper researchers looked into the history of Lake Superior's copper mines, the more difficult it became to dismiss the comparison without investigating it further. More than 30 years after Charles Whittlesey documented the immense prehistoric mines around Lake Superior, another piece of the puzzle emerged from a very different source. It wasn't uncovered by geologists, it wasn't found during an excavation, it survived in memory. In 1894, a researcher collecting traditions that were later preserved by the Wisconsin Historical Society recorded a series of oral accounts from Ojibwe elders whose families had lived around Lake Superior for generations. Among those traditions was one account that immediately caught the attention of later researchers, not because it claimed something impossible, but because it described events that seemed unexpectedly familiar when compared with the archaeological evidence. The elders did not say their ancestors had discovered the great copper mines. Instead, they spoke about the people who had worked them. According to the tradition, strangers arrived from the east by crossing the Great Water in large vessels. They were remembered as experienced miners who appeared to know exactly where the richest deposits were located. Rather than wandering the landscape in search of copper, they travelled directly to the mining districts and extracted the metal on a scale unlike anything the Ojibwe themselves remembered seeing. Whether every detail of that tradition reflects historical events is something historians continue to discuss. Oral traditions, like written records and archaeological evidence, must be studied carefully and compared with other sources. But what makes this account remarkable is how closely some of its descriptions resemble discoveries that archaeologists would later make in the ancient mines themselves. One detail appears again and again throughout the account. The miners used fire to break the rock. The elders described large fires being built against exposed stone until the rock became intensely hot. Water was then poured over the heated surface, causing it to crack, so the copper could be removed more easily. For modern archaeologists, that description is immediately recognizable. It matches the fire-setting technique identified throughout the prehistoric mines of the Lake Superior region. Long before these traditions were recorded, excavations had already revealed burned rock faces, ash deposits, and fracture patterns consistent with exactly this method of mining. Two entirely different sources, archaeological investigation and indigenous oral history, describe the same basic technique without relying on one another for their origin. That overlap does not prove every part of the tradition, but it does show that the mining practices remembered by the elders are consistent with evidence preserved in the ground. The tradition continues with another striking detail. After the copper was removed from the mines, it was carried to the shoreline. There, according to the elders, the metal was loaded onto waiting vessels before the strangers departed across the water. The account does not identify these people by name. It does not explain where they came from, how often they arrived, or where they went after leaving Lake Superior. Instead, it preserves a simple pattern remembered across generations. They came, They mined, they loaded copper onto boats, then eventually they stopped returning. It is important to be clear about what this tradition can and cannot tell us. By itself, it does not demonstrate that Bronze Age sailors crossed the Atlantic. It does not prove that the copper aboard the Uluburan ship originated in North America. Oral history is one form of historical evidence, and historians evaluate it alongside archaeology, written documents, environmental data, and scientific analysis. No single source, standing alone, is enough to settle a question of this scale. But historians also know that oral traditions sometimes preserve genuine memories of real events for centuries. Around the world, researchers have found indigenous accounts that accurately describe volcanic eruptions, ancient coastlines, and environmental changes later confirmed through geology and archaeology. That is why these accounts deserve careful study rather than immediate dismissal. What makes the Ojibwe tradition so compelling is not that it answers the mystery. It doesn't. It is that it unexpectedly intersects with evidence from entirely different fields. Archaeologists found ancient mines worked with fire setting. Radiocarbon dating showed those mines were active during the Bronze Age. Geologists documented an immense quantity of missing copper. Scientists later identified unusual isotope results in part of the Uluburan cargo. Independently, an indigenous tradition remembered organized miners arriving from across the water, extracting copper with fire, and transporting it away by boat. Each piece of evidence has its own history. Each can be studied separately. Yet when they are viewed together, they begin to form a pattern that is difficult to ignore, not because it proves a forgotten transoceanic trade network, but because it raises questions that archaeology has not yet fully answered. For the first time, the shipwreck resting beneath the Mediterranean and the abandoned mines hidden around Lake Superior no longer appear to be two unrelated mysteries. Instead, they begin to look like two fragments of a much larger story, one that historians are still trying to reconstruct from evidence scattered across two continents. Long before isotope testing drew attention to Lake Superior, the region had already become one of the greatest archaeological puzzles in North America. The mystery wasn't hidden beneath the water, it was buried beneath the forests. When American mining companies moved into Michigan's Upper Peninsula during the 1840s, they believed they had discovered one of the richest untouched copper deposits in the world. Native copper was visible near the surface, and investors expected decades of profitable mining ahead. But as surveyors pushed deeper into the wilderness, they began finding evidence that changed the entire story. Someone had reached these deposits long before they had. Across the Keweenaw Peninsula and on Isle Royale, hundreds of ancient excavation pits appeared beneath layers of soil and dense woodland. Some were little more than shallow depressions, while others descended deep into solid bedrock. Massive trees had taken root inside many of the abandoned workings, their trunks growing directly from pits that had already been deserted for centuries before Europeans arrived in the Great Lakes. These were not isolated discoveries. The further 19th century miners expanded their operations, the more ancient workings they uncovered. Instead of opening untouched mines, they often found themselves reopening ones that had already been excavated by people whose identities had long been forgotten. The evidence became even more convincing once excavation began. Workers repeatedly uncovered thousands of heavy stone hammerstones lying beside exposed copper veins. Many still carried the grooves where wooden handles had once been secured. Others remained exactly where they had been dropped, slowly buried beneath centuries of accumulating soil. These weren't ceremonial objects placed in graves or ritual sites. They were tools worn smooth through constant use. Every hammerstone represented another miner, another shift of labor, another day spent extracting copper from solid rock using nothing more than stone, wood, fire, and remarkable experience. The rock walls preserved another clue. Archaeologists found widespread evidence of fire setting, an ingenious mining technique used thousands of years before explosives existed. Large fires were built directly against the rock face until the stone became intensely hot. Cold water was then poured across the heated surface, causing the rock to crack under the sudden change in temperature. Once fractured, the bedrock could be broken apart with stone tools, exposing the native copper trapped inside. It was an effective method, but not a simple one. Fire setting required planning, patience, and generations of accumulated knowledge. It reflects an organized mining tradition, rather than occasional attempts to collect copper from the surface. Whoever worked these deposits understood the landscape exceptionally well and had developed techniques capable of extracting enormous quantities of metal long before iron tools ever existed. The next discoveries answered one question while creating another. Preserved wooden timbers recovered from several ancient mine shafts were later subjected to radiocarbon dating. Many dated between 3,000 and 5,500 years old, placing large-scale mining squarely within the same broad era that Bronze Age civilizations across the Mediterranean depended on copper for tools, weapons, trade, and industry. The timing immediately caught researchers' attention. The world's largest known prehistoric native copper district had been operating during exactly the period when demand for copper was reaching extraordinary levels thousands of miles away. Then came one of the most debated estimates in the history of North American archaeology. After surveying the ancient workings, federal geologist Charles Whittlesey concluded that prehistoric miners may have removed between 1.5 and 2 billion pounds of native copper from the Lake Superior region. Modern researchers continue to debate the precise figure, and many consider the estimate too high. Even so, few dispute the central conclusion that prehistoric mining around Lake Superior was carried out on a truly remarkable scale. This was not a handful of scattered pits. It was one of the largest ancient mining landscapes ever identified in North America. That scale introduced a question archaeologists are still discussing today. Copper artifacts made from Lake Superior metal have been discovered across North America. Spears, fishhooks, knives, awls, ornaments, and ceremonial objects demonstrate that extensive trade networks certainly existed throughout the continent. But when researchers compare those surviving artifacts with the enormous quantity of copper believed to have been extracted, the numbers appear difficult to reconcile. Where did the rest go? Was much of it recycled over thousands of years until little survived? Did it move through trade systems that archaeology has not yet fully reconstructed? Or are there chapters of prehistoric exchange that remain completely unknown? No single answer has gained universal acceptance, which is precisely why the question continues to attract attention. Then researchers noticed something that made the mystery even harder to ignore. The period of peak mining activity around Lake Superior overlaps remarkably well with the height of Bronze Age copper demand in the Mediterranean. By itself, that overlap proves nothing. Civilizations can flourish at the same time without ever meeting. But when a massive prehistoric mining district, an unusually large quantity of missing copper, and an ancient shipwreck carrying 10 tons of metal all begin appearing in the same conversation, historians naturally ask whether the similarities are simply coincidence, or whether another piece of the story has yet to be uncovered.